Hi, my name is Ash, and this is my task 3.7, the Arduino project. For this task, I wanted to create something practical that could actually be useful in the real world. So I built a smart gas hazard response system using Arduino and simulated everything inside Tinkercad. As you can see on my screen, this is a Tinkercad website. Now let me walk you through the components I used and why I choose them. The core of my system is gas sensor, as you can see, and this detects flammable gases like methane, LPG, or smoke, or uh, any other gas. So I choose it because gas is the main thing I'm trying to monitor and react to on my project. So this is what drives the whole system, to be honest. Next, I have used photodiode sensor along with a 10K resistor. As you can see, this part checks whether the room is bright or dark. Basically, if the room light is on or off, it helps the system decide how risky the situation is. For example, if gas is detected but the light is already off, that's less dangerous than gas with the light still on. That's why this sensor plays an important role and not just something I added for the sake of having two sensors. So in here, this in the real world, it like it works like automatically, but in here we have to adjust the light. So and the other thing I have used is like the buzzer to make a sound whenever gas is detected, so people are allowed it even if they are not looking at the system. I also added two LEDs, as you can see, one green, one red. The red LED that turns on when gas is detected, and green LED that shows when everything is fine. To simulate the room light, I use a bulb LED connected to pin D8 through and resistance. The light turns on under normal condition, but will turn off instantly if the system detects a gas leak. This simulates how a real smart system could cut power to a light fixture during an emergency. Finally, as you can see, I use a LCD screen to display live gas and light reading and show clear messages like all clear, gas hazard, or gas leak safe. It gives you live feedback about what the system is doing and helps anyone nearby understand the situation. All of this wired to an Arduino owner and placed on the virtual breadboard in the Tinkercad. The whole thing is running live and continuously check for danger. Now I will show you how the system works in the action. So let me show you in the action. So right now everything is in the normal state. There is no gas leak, no the room light is on, the green LED is on, the bulb is on, the buzzer is off, and the LCD shows all clear as you can see here. This is, I would say, the safe condition of my project. Now I'm going to simulate a gas leak by increasing the gas value. At the same time, the room light is still on, which makes the room that makes this more dangerous. As soon as the gas is detected, the system reacts instantly. Let me show you. So let me explain that to you that the bulb turns off automatically, the buzzer stops buzzing, the red LED turns on, the LCD updates to say gas hazard. So this shows that the system doesn't just sit there, it takes action to reduce the risk. So let me show you one more time. So the reset, so once the gas level returns to normal, everything resets. So the green LED comes back on, the bulb turns back on, the buzzer goes silent, the LCD says all clear again. This reset happens automatically and gives a real sense of system running live and independently. So um, why does this matter in real life? So imagine the system in a real kitchen, um, near a gas stove. If a leak happens, and someone flicks the light switch, that tiny spark can cause an explosion. But if this system is installed, it would shut down the light immediately and warn people before anything serious happens. It could be used in homes, restaurants, labs, or even garages. Anywhere gas might be present there, even in your house. In excuse me, in terms of what I have learned, I got more confident working with analog sensors and understanding how to set them in proper way. I learned how to wire a photodiode with a voltage divider, how to control different outputs like lights, buzzers, and LEDs, and how to write code that responds to multiple sensors at once. I also improved my debugging skill, especially when switching from an 12C LCD to a standard one using a potentiometer for contrast. So let me show you my potentiometer. As you can see, I can adjust the brightness here. So this project felt real to me, not just like a school task. It's something that could actually help people, and I'm proud of how it turned out at the end. So thanks for watching my task 3.7 the Arduino project, and goodbye.